Okay, today we're going to look at Voronoi diagrams. So with a Voronoi diagram, we want to learn this vocabulary, make sure we learn the terms site, edge, vertex, and cells, and that we can solve problems using Voronoi diagrams. So firstly, this builds on the concept of perpendicular bisectors. So let's just remind ourselves of a perpendicular bisector. If we take any 2 points, any 2 sites like these ones, we can construct the perpendicular bisector by first we find the gradient of the line between the point that passes through points A and B. Once we found this line and its gradient particularly, we can find the midpoint of the line, and it's going to be here at this point. So the perpendicular bisector has the negative reciprocal gradient of the line AB, and it passes through point C. So we can make that line like this. Now what's special about this line is that if we have a point on the line of the perpendicular bisector, then all of the points on that line are equidistant from A and B. So for instance, let me just show this. There we go. So what I've done here now is I've created the, so we can just hide that now. We don't need that. So we've got the points A and B. These are our 2 sites. We can construct the perpendicular bisector, which passes through the midpoint and has the negative reciprocal gradient of the line AB. Any point on this is going to have the same distance to A that it has to B. And we can see that here. So any of the points on this line are going to have the same distance from A and B to that particular point on the line. So this is the concept of a perpendicular bisector, and one of the most useful things about it is this equidistance. So we're going to use this idea to create a Voronoi diagram. Let's have a look at the problem we're trying to solve. We have 3 hospitals located as shown. So we're going to have one hospital at A, which is at 1, 8. Let me just pop that one in. 1, so let me shrink this a bit. There we go. We are going to have first point is going to be at 1, 8. Let me just move this over. We've got 1, 8. Oops, nope, that's here. Our next cell is going to be 8, 8. This is at 8, 8. And our last site is going to be at 3, 2. So we need another site here at 3, 2. Our task here is to try and figure out if we have an accident at 5, 6, point P, which hospital is going to be closest? Now, looking at it and eyeballing it, we can probably see that A looks a little bit further away, but C and B look pretty close to each other. The way this problem is solved is we can create a Voronoi diagram. So I'm just going to go Voronoi, and then I'm going to give a list of points A, B, C. This will draw the Voronoi diagram for that particular point. Have I got my cells? I've not got my cells in the right place. This one is at 3, 2. There. So this edge here is the perpendicular bisector of B and C. So let me just get my highlighter pen. This edge here is the perpendicular bisector of cells of sites B and C. This edge here is on the perpendicular bisector of sites A and B. This edge here is on the perpendicular bisector of A and C. And this creates the Voronoi diagram. So any point on those edges is equally distant from B and C, or any point on this edge here that I'm erasing is equally distant from A and C. And the vertical line there, any point there is equally distant from A and B. That means that any point this side of these edges lies in what we call cell B. All of the points in cell B are closer to site B than any other site. All of the points in cell B are closer to site B than any other points. P lies in cell B, which means it is closer to site B than it is to site A or C. That's because these lines, these edges, are equally distant from any other point. An interesting point in this one is the vertex here. This vertex here where the three edges meet is going to be equally distant from A, B, and C. So that's one of the interesting parts about that one. Okay, this is a classical math problem called the toxic waste dump problem. We have a space defined by the axes and the line x equals 10, y equals 10. And we have 4 towns located at different points. So the first one is point A, which is located at 2, 7. So 2, 7 is going to be here. This is point A. Point B is up here at 9, 9. Point C is at 2, 3. And point D is at 7, 2. We're tasked to find the best location for a toxic waste dump so that it's as far away from each of the 4 sites as possible. So what we do for that is we're going to create the Voronoi diagram. So Voronoi, and then I'll put in the points A, B, C, D. We make the Voronoi diagram for this. Now, if you remember, let me see where my highlighted pen is. Oops. So if you remember, this line here is the edge AB. So this is the perpendicular bisector of the points, the sites A and B. All of the points on this edge are equally distant from A and B. This line here is the perpendicular bisector of points B and D. All of the points here are equally distant from the sites B and D. This line here is the perpendicular bisector of A and C. All of the points there are equally distant from A and C. This edge is the perpendicular bisector of C and D. All of the points are equally distant. This one's a little tricky. This is on the perpendicular bisector of A and D. Sort of runs like this. So it's equally distant from A and D. Because these points are closer, it sort of cancels it out, it cuts down to here. But we end up with an interesting fact. We have 2 sites. We have we have two vertices here and here. We want to determine which vertex is furthest from everywhere. So what we can do is I'm just going to put a point here on these two vertices. Okay, so if I draw a circle with center E and a circle at center F, watch what happens. If I draw a circle, center E, and I extend it out to here, what we can see now is all of the points, all of the sites A, C, and D are going to be equidistant from point E. If I do another one at F, we notice that all of the points, all of the sites A, B, and D are equidistant from F. So we want to have the shortest possible distance. So what we want to do is which of those is the bigger circle. So we want to have the largest possible distance. It's a toxic waste dump after all. So we want the largest distance. So if we look at the distance from F to B, it's 4.16. If we look at the distance from E to any of these points, it's 3.61. So what this tells us is that site F is further from any of the towns than any other point. And this is the solution to the toxic waste dump problem.